Hi everyone, welcome to this video. It's just going to be a discussion a little bit deeper on sampling. I want to make sure that you understand it and are able to actually do it for yourself. And then the memo is in the second half for the exercises. So I'm going to do this first, then I'll tell you where to stop. Make sure you've done the exercises before proceeding. Okay, so in the previous sections that we have now covered, we have this concept where we're talking about a population, and then we want to make conclusions about the population based on a sample. So one of the important things that I want you to pick up, at least understand rather, is the difference now between your population and your sample. So your population is just the whole group that you are interested in knowing more about, and then a sample is just a subset of that. So now let's consider this example here. What is the average electricity bill of households in Pretoria? If I ask you to identify the population, what would you identify? Maybe take a moment to write it down. Okay, so hopefully you have committed your answer. The population in this case, the group that you're interested in, is all households in Pretoria. So that's the population where you're asking this question about and you want to know more about. Now, it's not going to be possible for you to now get each and every single electricity bill in Pretoria. So you're going to take a sample. And there are these 5 techniques that we have highlighted for getting a sample, and I want to show you how you can get these different kinds of samples and help you understand the difference. So this is just a summary to help you see the difference just visually. In the simple random sample, you're literally just picking people randomly. So maybe you pick someone there, someone there, someone there. And you're picking them independently. So it doesn't matter what you picked before. The next thing is just going to be a random selection. Then you can see under systematic that there is a clear pattern. So there is a system that you're following. And then I'm going to move to clustering just below. So you see here you have different groups, 5 groups in particular. And then with cluster sampling, you take the entire group. Now with stratified, here once again, you actually have 2 groups. And you can see the 2 groups have similar characteristics. And now what you're going to do once you've identified these groups, the groups are called strata. These groups now, what you're going to need to do is then do a random selection within the group. So this will ensure that you get a little bit of each characteristic. So you get some green and you'll get some blue. Okay? So let's now look at them in a bit more detail. So with simple random sampling, this is something that you need to be able to do using a number line, but it's also possible to do it in Excel. I'm not going to cover that here, but I'm going to show you how to do it with the number line because that's something that could come up in a test or an exam. So this is what typically happens. So let's think about that example where we wanted to find out the average electricity bill for houses in Pretoria. And what I have here on this far right hand side is a table with all the different suburbs. And let's assume that we can actually sample everyone in the suburb, so we can get every single bill, like we have lists or something like that. So now we need to decide, okay, we need to pick 3 suburbs. How can we do that using simple random sampling? So one method of doing it, like I said, is with this number line. So there are actually tables that have numbers and numbers and numbers that were randomly generated, and there's no relationship between the numbers, so they're totally independent of one another, and you can use that. The independence within the numbers, it transfers automatically to your selection as follows. So the first thing you're going to do is you're going to look at your sample and you're going to see how many observations do you have. So we see we have 24. Now when you go to your number line, you are going to split it up into 2-digit numbers because you have a 2-digit sample size. So you're going to cut it into 2-digit numbers. Okay? So you get the idea. And then you will take the observations that exist. So here we have 95, but we don't have a 95th observation. So we can't take that one. Then we have 13, which we can take. So let me erase this. So that means we would take Hatfield as one of the areas that we're going to sample. There's no 83, but there's a 6. So we'd go to Vanderboom here. And then we don't have 73. Oh, but we have 22. So that would have us pick Mamelodi. So that's how you would pick a simple random sample. So you can carry on depending on the sample size that you desire. Now, suppose your sample, your population. So this is your population, every suburb in Pretoria, only had, let's say, 9 observations. So you didn't have all of these. Here you only have 1 digit. So you're going to split it into single digits. Okay? If you had hundreds and hundreds, then you split it into 3 digits. Okay? Because now if you only split into 1 digit when you have, let's say, all 24, then you'll never be able to pick any of the 2-digit numbers. So that's why you need to split it into 2 digits. So then generally, when do you want to use this kind of sampling? You want to use it when the members in your population are kind of similar to one another. So there's no distinct difference between, let's say, Soshangove, Mabopane, and even that one, and amongst themselves and so on. Like, they're kind of similar. So then you can pick a random sample from them. The advantages of this approach, it has a high degree of being representative. So when we say being representative, we mean we want it to be almost like a mini version of the whole population. So it represents the big population well. So here it will represent well if you pick them randomly, but the disadvantage is that it can be time consuming and tedious. So if you remember in our example where I think we had Brooklyn and we had Mamelodi, and I think we also had, let me quickly go back, number 6. Okay, so these places are quite far apart. So imagine the time and the cost of going to all these places. So it can take a lot of time. Now, with systematic sampling here, you follow a system. So here I want to take 3 suburbs, but I have 24. So what you do is you'll take the 24 and then you'll divide by 3, and that will give you 8. So you want to take the 8th one. So you'll start counting 1, 2, 3, 4, 5, 6, 7. We take 8. And then 1, 2, 3, 4, 5, 6, 7, 8. You see? 1, 2, 3, 4, 5, 6, 7, 8. So our sample now consists of Montana, Irene, and Broncosprit. So you want to use this in a similar case whenever these are quite similar, once again, like we said. And the great thing about this is that you also have a nice representative sample and you don't need to use any tables, which is cool. Unfortunately, though, there is less randomness. So in the previous one, it was totally random, but here there's a clear pattern. And that can be an issue, let's say, if you arrange these things such that every 8th one was, let's say, a town that is in Pretoria Central, then you know that all the suburbs will come from the same area. So it depends on the order. That's what they mean by saying it is less random. And then for cluster sampling, here what you're going to do is firstly divide your population into groups. Each of these little groups have a special name. They are called clusters. Okay? And in these clusters, ideally you want them to be representative as well. So they must be like mini representations of the whole population. So let's say you have a rich suburb, poor suburbs, you have high density, you have places where there's fewer people. Try to get that in each group. Okay, so you don't end up with one group where it's all people who are in rich suburbs, for example, because that could bias your results. Like you might not get a good representation of the average cost of electricity in that scenario. So once you have your groups now, so I've pre-divided them into my groups, which are called clusters. Then what you do is you now take a random sample of the clusters now. So referring back to my example, the first one where we did random sampling, you check how many things are we picking from. You can see we have 8 clusters. So therefore, this is a single digit. So we need to use our number line and split it into single digits. Okay, so we're not going to take 9 because we don't have a 9th cluster, but we have 5. So that means we'll take the 5th cluster, and you take everything that is in the cluster. And automatically those are your 3 observations. And when are you going to use this? When you have these units. So you can see these kind of groups and clusters, and that's when you want to use cluster sampling. The advantage is that it's easy and it's convenient, but the disadvantage is maybe within a unit you will end up with the units being very, very different from one another. So imagine if all of these happen to be in the same region and these ones were much further, then these 3 areas, they might not represent the whole of Pretoria very well if they're just located in the same area. So that's the disadvantage. Your clusters might not be representative of your population. Then for stratified sampling, this one is similar to your clustering, but here you have your groups again, but then there's something that is linking everyone within a group. So they have some characteristics that might be important. So for example here, I have divided them into regions 1 to 7. And note well, all of these groups have specific names. These are now called strata. They're not clusters. These ones are called strata. And within a group, these suburbs are actually more or less in the same area or region in Pretoria. So this one's easy to understand. You're in Hatfield, and you're not too far away from Brooklyn and CBD, and Pretoria West is not too far away from CBD. And then you have Irene and Centurion, and those are more or less in the same region. And now the reason why you want to now group them according to some kind of characteristic of importance is because in your sample, you want to make sure that each region is represented, because the region might actually have an influence on the electricity bill. So for example, if you have suburbs which are richer than others, you need to make sure that your sample at least has some rich suburbs, some less affluent suburbs, and so on. So what you do is you can divide them accordingly. So in this case now we're looking at regions though. So there are these divisions, they're not necessarily equal. And in these regions, what you're going to do is now take your sample in proportion to the number of regions in each area. So you can see here you have 4 suburbs, 4, 4, 2, 2, 4, 2. And now what you're going to do here is I still want now, let's say a sample of 11. And I know out of all of these, altogether these are 22. I did tweak the table a little bit. So now they're 22 instead of 24. But don't worry about that. It's just for the purposes of the example. So out of these 22, 4 of them come out of region 1, right? 4 out of 22. So in your sample of 11, 4 over 22, that fraction must come from region 1. So when you work this out, I guess that'll give you 2, yeah. Then you're going to take 2 from region 1. So we're going to make sure to sample 2 from this region. And then you also have 4, so you also need to sample 2 from there, 2 from there. But now in these smaller regions, we don't want them to have too much weight. So we also need to make sure that we only get 2 out of 22. So you must follow the proportions. And here, you'll end up with 1. So we only sample 1 from here and 1 from there and so on. Now, here, if you now check the total, 2 plus 2, 6, 7, 8, 9, 10, 11. So that you end up with 11, and they're distributed now proportionately to the number of suburbs in the region. So now you'll use your number line to do a random sample again. So here we have 4. So remember, it's a single digit, so we break it up into 4. So here, we're not going to take the 9th one because there's no 9th. We can't take the 5th one because there's not 5 in that group, but we can take 1. So we're focusing on region 1, by the way. And then 3 as well, because there is a 3rd one in that group. Then you are going to redo that process and do it in here. And you'll redo it for each and every single group. And I think in practice, maybe you want to continue with your number line or use a different number line altogether. But that's something we would then be clear for the purposes of a test or exam. So now, when do you use this? When your population is heterogeneous and contains several different groups. So basically what they mean is that there are clear differences between the observations, and you can actually group them according to those differences. And then the advantage of this is now you have a high degree of representativeness. You don't have a situation where you might end up only taking these guys who are in Pretoria Central and then end up trying to make conclusions about all of Pretoria based on those ones only. So you have this great representativeness, but unfortunately it can be quite time consuming and tedious. Firstly, going through all of this, finding all the groups, and then now you have to go to Soshanguve, Vinterval, and then you have to go to this region 2, region 3, 4, and so on, all over Pretoria. So definitely in this example, it'll become time consuming and tedious. And then lastly, a convenience sample doesn't involve any probabilities anymore. So it's at the bottom here. You just take whatever's convenient. So it could be anyone who volunteers. That's just the easiest. Or if you're taking people who walk into your school, the first 10, 20 people. So it's just the easiest. So you're going to use this when it's convenient, I guess, but it's not ideal, but it's most commonly used. And you're also going to see the advantages is it's very convenient, of course, and inexpensive. The disadvantage is that now your sample may not be representative. So if you only take the volunteers, what if the ones who don't volunteer or the ones who are inconvenient to sample are actually important? So that brings me now to your summary back here. So you can refer back to this, and then now you can see how use this to help you now remember which is which and how to do each one. So all of them generally need you to use the number line. So remember here, you pick each one according to the number line. Oh, except for this one where there's no number line and you follow a system. And then here where you group them, ideally you want the groups to be representative, and then you sample entire groups. And then you have here where you group them once again according to some characteristic, and then you sample within the groups in proportion to the number of observations in the group. So hopefully this will help you remember. So if you have not done the exercises, I would like you to do them now. So this was just to help you so that you don't get stuck. Please attempt the exercises on your own and then come back to this video, and then I will show you the memo, and I will discuss it as well for the things that might have been a bit challenging. So just pause the video now, do your exercises, and then come back. Okay, I'm assuming you have done the exercises. Let's have a look at the memo. So what I have here are just the answers. So you can pause the video now and check your answers. And then if you feel that you are comfortable with everything that we've covered, then you don't have to carry on in the video. But I'm going to carry on with some explanations for those who may have gotten stuck. And also, if you did get something wrong, maybe take a moment to have a look and see where you went wrong for yourself. Try to figure it out, because that's how you learn before you listen to my explanation. So if you get really, really stuck and you've tried your best, then continue with the video and see my explanation. Okay, so for those of you who are still with me, let's carry on now. So a study is being planned, and they want to determine if more first years in South Africa pass math stats than fail. And they take a sample of 100 first year students and they record their marks. That's basically what the question is saying. So the first thing you're asked to do is to identify the population of interest. So when you get a question like this, you want to ask yourself, okay, what am I interested in sort of studying? Okay, so I know that I want to look at the proportion of those who like pass and fail. That'll tell me the answer. But who am I focusing on? What is the group that I'm interested in? And if you look at this now, we know we're not just interested in anybody. We're interested in first year students, but not all first year students. We want them specifically to be in South Africa, but we're focusing on their mathematical statistics. So you need students who have done mathematical statistics. You can't take students who haven't done mathematical statistics. So you need to make sure you have all three of these aspects because these are defining the group you're interested in. So you'll see here all first year mathematical statistics students in South Africa. Now, which is the sample they obtained? They didn't explicitly use the word sample, but remember a sample is just a subgroup of the entire group. So remember all of the first years in South Africa, that could be people at UCT, people at UP, people at Wits. There are so many universities. So it will definitely be tedious to try get all the marks for everyone if we didn't have a database. So what we did is they took 100, and I'm sure you know there's definitely not 100 first year math stat students in all of South Africa. So this is clearly a subset of the entire population. Therefore, this is your sample. So you must say the sample obtained, it's 100 first year students, specifically those who did mathematical statistics, and they are from UP. So all those aspects need to appear in your answer for you to get the full marks if this was a test that I was marking. And then in part B, do you think that the sample is representative of the population? And what I'm asking here, when you look at this sample, can you think of it as a mini version of the full population? Does this sample represent all of the characteristics of the entire population? Or at least, if not all of them, most of them. That is what will make a representative population. And in this case, the answer would be no. I hope you agree with this. No. The reason being that students at UP, they cannot possibly represent all the students throughout the country because students from different universities will have different characteristics and we're going to miss out on their information. Therefore, we're going to say no. This is not an ideal representative sample because of that. Now in C, how can we improve the sampling scheme? If you remember previously, when we talked about the different sampling schemes, there was one, I hope you remember the name, where you actually managed to get characteristics of, let's say, the different universities in this example. And specifically that one was stratified sampling. Okay, so stratified sampling would have you look at, okay, how many students are at UCT, how many are at UP, Wits, and so on, and then you'll sample the 100 proportionate to how many there are in each university. So now you get representation from each university. Okay, now we're here. So remember I said you have UCT as one of the universities, you have Wits, you have UP, there's so many of them. And if you were doing cluster sampling, then that could have actually been how you ended up with UP only, because these actually could represent your clusters as well. And then instead of sampling within each of the group, you just take the whole group. That'll give you a clustering. That'll give you a cluster sample. Versus a stratified sample, we'll take a few from each of the universities. Now they say name two categorical variables which you would be interested in to include in your data set. So now when you go to the universities now, let's say you go to UP and you have these 100 students and you want to compile all their data. So I guess we don't really need the name, but we can get, let's say, the student ID, all right? And then we'll jot them down. This is now for each student. So let me add a column for the student number 1, number 2, 3, 4, 5, and so on, all the way to 100 of them. For each of them, maybe we'll get their student numbers, maybe we won't. This one is not that important, but you just need a way to identify who's who. So it could either be an observation number or your student ID. This question indeed is asking you, okay, what else can we record for each student that is specifically categorical and not numerical? So perhaps we want to measure their gender. I'm just going to call it G. So then maybe there's a difference between males and females. So it's important to record, are they male, are they female, etc. Whatever categories you're using. And then maybe another thing is you want the type of matriculation. So which kind of board were you writing on? So remember, some people, maybe they do O-level, some people do IEB. So not everyone's doing the same exam, so it matters. So maybe you want to record that here. I'm going to call it T. Okay, so then here, for each student, you record which board did they write on, because that could have an impact. And then obviously, if you want to know whether they passed or failed, you need to know the mark symbol in this case. So maybe whether someone got an A or a B or a D or an F or whatever it is. So let me just call this M. So this is what the question was asking you. What kinds of things would you want to record about them? And specifically those which are categories. So categories are not things you measure. They're things that are groups. So, with your grades, you are either A, B, C, or D. It's not numerical, for example. So we wouldn't have put like percentages. Like let's say someone got 90%, someone got 45%. This is not categorical, it's numerical, so this wouldn't have been a correct answer if that's what you supplied. And then in E, suppose that now you have the metric symbol for mathematics, which is 1 to 7, and you denote this by X, and then the age of each student is denoted by Y. Give the variable type for X and Y. So remember X, I'm going to write it out here. They told us that X is the symbol. Suppose that the metric symbol. And then they said Y is the age. Okay. So remember, random variable is just a characteristic that can take on, it's like a measure, something you can take on different values. So we call it a variable, and then we add random variable because it can take on a random value. So for each student, we can measure X and Y. So if we, let's say, come back to my table and I clear up these, for each student, we can report X and Y, and these will take on random values. And then they're asking us, okay, but the things we're filling in here for X, what type of a variable is that? Is it categorical or numerical? That's basically what it's asking. And for X, which is going to be a symbol, it's 1 to 7. So remember, even though these are numbers, you can't get like a 1.2 or a 3.4. You either have a 1 or you have a 7 or whatever, a 2. So you all of them will fall into one specific category there, right? And then you also have Y, which is now numerical, which is the age. And I think that one's understandable because you can be 5 years or 5.25 years or 5.9 or 10.11. Like you have this measurement on this continuous scale. So it is numerical. So then for question 2, this is now a recap. Now, this is the sampling. So now you have these 21 students. They enrolled in a class. and you need to select a sample, and there are different sampling methods. So let's check how you should have gotten this. So first thing you should do when you get this is understand, okay, what kind of sampling do they want? They said simple random sampling. And then they said, what size should this be? And they told us you want 2 observations. They say from the list, so note they're in alphabetical order going down each of the columns, all right? They say use the random numbers below to read from left to right. Oh yeah, sorry, read numbers below and you read the numbers from left to right. So the first thing you're going to do is decide, okay, how am I going to divide my number line? 2 digits, 1 digit, 3? And this depends on how many observations you have. We have 21 observations, so that's 2 digits. So we need to split it into pairs of 2 digits. Okay? And then now we see, do we have a 55th observation? No. A 58th? No. We don't have an 89. Our sample is only 21. We don't have 94, but we can get a 4th one. So that's 1, 2, 3, 4. So that's how they got Kirsten. We don't have 70 or 70. So you actually kind of have to keep going with this one. 70, 84 until you get to 10. So Kirsten was 4. So 5, 6, 7, 8, 9, 10. So that is your random sample of 2. So that's how you get that answer. And then they say now draw a systematic sample of size 3, starting with Mayepu. So remember, the systematic one is where you have a pattern. But here, okay, they want size 3, systematic. So we need to take the entire population and then divide it into thirds. And then we'll take whoever is in the 7th position. But they said you must start with Mayepu. So we're definitely going to take Mayepu. That's where we're starting. I'm not sure if it was very clear. So I'm going to definitely make sure that in a test and exam, it's very clear. So this question is from a past paper. But don't worry about it. I will make it very clear whether to include Mayepu or not. So here we want 7. 1, 2, 3, 4, 5, 6, 7. So we've got Rothman. And then, and the next one, 1, 2, 3, 4, 5, 6, 7 here. So you need to now go back to the top of the list and start counting again. So that's how you get the last one there. So that's that answer. Now, they said let each row represent a cluster, and then now you need to pick a cluster. So remember, clustering is the one where you have the groups, but you don't pick within the groups. You only take everyone in the entire group. So you need to use the random numbers because it is still random selection, and they want here a sample of size 3, and they want you to use cluster sampling. And then they said the clusters are represented by each row. So that means this is cluster 1, this is cluster 2, and so on. Using your number line, you can see at the end of the day you end up with 6 clusters. So that's a single digit, therefore you break it up. Okay, so we don't have a 9th cluster, but we have a 6th one. So this is the sample that you're going to give, where you're going to collect results from. So that's how they got this. Cluster 6. Read from left to right. 1, 2, 3, 4, 5, 6. Apologies. This is 6. There are actually 7 of them. My apologies. So that's how you get Kunene, Negrini, and LaRue. Okay, so I hope that helped you. Those are typical exam questions. I actually got them from past papers. So if you're able to do those, and even if you made a mistake and you will be able to do it in future, that's great too. So this is the end of this. I hope this was a helpful session. If you have any remaining questions, please post them on the discussion board, and you're welcome to also consult, and we'll help you with any issues that you may have. All right. Enjoy the rest of your day.